Talking about the definition of a derivative. What is a derivative? So, I know all of you have, or most of you have heard that it is rate of change. But what would rate of change actually be? That's delta y over delta x. If we're measuring the rate of change of y with respect to x. And how would that look? That would look something like this. And if you had some function here, and you draw a tangent, let's say your function was like this, and you draw a tangent, something like this, and you take the slope of this line at these points. So this would be y2 minus y1 over x2 minus x1. And that's your slope, or m. And that's your y2 minus y1 or x2 over x2 minus x1. And that's your delta y over delta x. Which means this is your average rate of change. But what is a derivative? What is dy over dx? What is dy over dx? And that's what we're going to be talking about today. So, if we draw an axis and then we we graph a function, it doesn't matter what function it is. Let's say it was something like this. Okay? And now we take 2 points. Let's say this is x1 and this is x2. Now, we want to find the derivative. How would that work? X1 would give some output f of x1, and x2 would give an output, and that's going to be f of x2. Now, what is x2? Let's say we added some distance h here. So x2 would be equal to x1 plus h. So we could write here f of x1 plus h. Now, what is the slope of this line that passes through these 2 points? What is the slope of this? So if we check our change in y, it would be something like this, and our change in x would be like this. So this is your delta y, and this is your delta x. Now, we know that the slope of this is delta y, so let me write this as m equals delta y over delta x. Now, delta y over delta x is y2 minus y1 over x2 minus x1. And we can see from here that y2 is f of x2, which is f of x1 plus h. So, this would be f of x1 plus h. And then what is y1? y1 is f of x1. So y1 equals f of x1. And this is just f of x1. Or we could just write it as f of x. We just write it as f of x minus f of x and change in x. What is our change in x here? You can observe that change in x is x2 minus x1. What is x2? x2 is x1 plus h, so let's write that down. So f of x plus h minus f of x, this is m, where delta x is x2 minus x1. And x2 is x1 plus h. And this is minus h. Minus x1. And on the numerator, we have f of x plus h minus f of x. So these would cancel out, giving you m equals f of x plus h minus f of x over h. Now, this is just our average rate of change. This is delta y over delta x. How do we find the instantaneous rate of change at one point? Because this is not accurate. This isn't the slope of this entire curve. This isn't the slope of the curve. This is the slope of this line. How do we find the slope of the curve? This curve right here. At any one point. That is what a derivative is. So if we use a limit here, and we reduce h to 0, so let's say limit h approaches 0, then you could see that this would get smaller, 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 until this is almost at one point. It's infinitely small. So your m would be limit h approaches 0, f of x plus h minus f of x over h. And this is your derivative. So you could, so you know how delta y over delta x, this is your average rate of change. Average rate of change of y with respect to rate of change of x. Now dy over dx, this is your instantaneous rate of change. Instantaneous rate of change at a point where this is what is it? Instantaneous change in y over instantaneous change in x. But this is not how you write it. You write it as dy over dx. So what do we get from this lesson that I taught today? Dy over dx, or it's also written as f prime of x, and this is equal to the limit of h approaches 0, f of x plus h minus f of x over h. And this is your derivative.